So guys, welcome to our channel once again. In this video, I have here these 3 questions to answer on the topic magnetic field. So guys, this video will be about magnetic field on a moving charged particle. So ensure to stay till the end of this video. Let's go ahead and start with the first question here. It says, a 10 microcoulomb charge moves with a velocity of 1.0 times 10 to the power of 5 meter per second at right angle of a uniform magnetic field of flux density 5.0 times 10 to the power of negative 40. Calculate the force on the charge. So guys, if we use the formula that force is equal to BLQ, where B is the flux density, then L here, we can use this velocity, and then Q is the charge. So we are going to have that this force will be the flux density 5.0 times 10 to the power of negative 4 times 1.0 times 10 to the power of 5, then times 10 microcoulomb. So 10 microcoulomb is 10 times 10 to the power of negative 6 coulomb. So let's go ahead and multiply this out. And then when we multiply this out, we're going to have 5.0 times 10 to the power of negative 4. And that's option A here, guys. So option A is the answer to this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 2. It says, an electron of mass m and charge E moves in a circular path in a magnetic field of flux density B. How long does it take to complete one orbit? So guys, to know how long it takes to complete one orbit, we are going to recall that F is equal to QVB. But guys, in this question, we are going to use E instead of Q, since the charge is represented as E here in the question. So that will be EVB. So let's also recall that F is equal to mv squared over r. So if we equate the two, that becomes EVB is equal to mv squared over r. So guys, in this case, we can cancel out one v from here and we eliminate the v from here. So in that case, we are going to have that EB is equal to mv over r. But let's take note that actually the distance it will take to cover this circular path is 2 pi r. So in that case, since the distance it will take to cover this circular path is 2 pi r, and velocity here is the distance or displacement over time, so we are going to have that this will become 2 pi r over t. So we can replace v as 2 pi r over t. So guys, the overall equation here now becomes EB is equal to m2 pi r over tr. So we can cancel out r, and then we have that EBT is equal to 2 pi m. So in that case, if we make t the subject of this equation in order to find how long it would take, that's the time. So t now becomes 2 pi m over be. So that's it for this question. Option B is the answer to this question. So that's it. Let's go ahead and consider the next and last question, guys. So that's question number 3 here, guys. It says, a proton of charge 1.6 times 10 to the power of negative 19 coulomb is projected into a uniform magnetic field of flux density 5.0 times 10 to the power of negative 5t. If the proton moves parallel to the field with a constant speed of 1.6 times 10 to the power of 6 meter per second, calculate the magnitude of the force exerted on it by the field. So guys, If we use the formula QVB, we're just going to have the Q, which is 1.6 times 10 to the power of negative 19 times the V, which is the speed here, 1.6 times 10 to the power of 6, then times the flux density B, which is 5.0 times 10 to the power of negative 5. So guys, let's go ahead and multiply this out together. So the answer becomes 1.3 times 10 to the power of negative 17 newtons. So that is for this question. Option B is the answer to this question. And this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below and we'll see you right there. Thank you once again for watching this video and see you on the next one.